Hello, this is Matthew Randall, and in this talk, what I want to do is have a look at removing noise from your renders, and specifically looking at removing noise from Arnold renderers. So there's two key sources of noise with renders in Arnold. One its source is from your lights, so not enough samples there to sample light sources. And another source of of noise is the number of samples you're using to sample the scene for each type of ray. So your subsurface scattering rays, your specular rays, your diffuse rays, your transmission rays, and your volumetric rays. Okay, so that's the two areas that we need to focus on. So the first area I want to have a look at, and typically kind of the first area I would look at in terms of removing noise is lights. Okay, and quite often if you have a noisy light, to fix that you're going to have to really up your samples quite significantly in order to fix a noisy light, where actually it's much easier to solve it just by upping the samples of your light. And when I say easy, what I mean is it's going to give you a similar result with less render time. Okay, hopefully that makes sense when we kind of go into the mathematics of how this sampling is done. So typically where you'll get your noise in lights is in the shadow areas. So what's happening is your camera is emitting rays into our scene, and it's projecting those rays through these pixels. Okay, and when it projects those rays, it hits a surface. And then from that point in the surface, it's going to emit a number of sample rays, all going to a particular light. Okay, and what we're trying to do here is by emitting these rays, we're trying to kind of see if this point on our surface here is actually occluded from the light or not. So in this example, we're hitting a surface here, and all the rays are hitting our light. So that would say so that point would be lit with would be entirely lit by that light, would have all the intensity of that light source. This one, all the rays are blocked, so none of the light from this light source would hit it. And here you can see that half of the rays are actually reaching the block. So this would be lit kind of 70% this point on the surface here. Sorry, 50%. Sorry, or you'd have 50% of this light intensity from on this surface here. And you can imagine that, you know, if you've got multiple lights for each point that you're hitting, you're going to have to emit rays, sample rays to each of those lights. So the number of samples for each light, quickly goes up depending on the number of lights you've got, and the number of samples you're using for your lights. Okay. And basically, a simple mathematics is if you take your AA samples, okay, and multiply it by your light samples, that gives you an idea of how many light rays you are emitting for your render. Okay, so that's just a very important kind of equation just to keep in mind there. Now your AA samples will actually be your camera AA setting squared. So if I just go into Maya, what I mean by that, I think I've got my render settings here. So it's this camera AA squared is the number of is your AA samples, and it's that multiplied by your light samples will tell you. Sorry. We'll give you an idea of how many times you're sampling that light per ray. So, for example, here we've got 2, so 2 squared is 4. If my camera light samples is set to 2, that would be 4 multiplied by 2. So we're sampling that light 8 times for each pixel. Okay. Let's go back to here. So it gives you an idea of that. And the key point behind that is obviously the higher the samples in our scene, the number of light samples in our scene, the longer that the render will take. Okay. Another area that you can get noise in your lights is in the actual specular highlight itself, although I don't find that a common problem. So mainly when I'm getting noise, I'm getting it from my shadow areas. So I'm just going to flip into Maya, into my little test scene that I've created here, and I've got all my kind of settings here set to 2. These are kind of like default-ish settings, and I've only got one light in this scene. I'm just going to move it here. It's already selected. And if we look in the attributes here, so it's in. So for your light, it's inside the Arnold attributes that we want to look. If you look in the attributes here, the light samples can be adjusted here. Okay. So what I'm going to do is I'm just going to take a snapshot of this. So I'm just going to go View, Store Snapshot. So I've got a snapshot of this, and if I up my light samples to say 3, let's see what we get. I might see if I can just pause while this is re-rendering. So this is with the samples to 3. I'm just going to go and store a snapshot there, and then hopefully what you'll see is if I go back to the old one, you can see there's the noise that we had in our original image, and just by upping the samples to 3, and it hasn't really made the render take that much longer. It's certainly less onerous than upping our ray types, our ray samples. You can see that we've got rid of some of the noise here, and I could just keep going with this and exploring this. Now, actually looking at this scene, in fact, yeah, I could keep going with this, but that's basically the essence of this. Is I can increase my samples here to get rid of the noise, and I can obviously just check it in my render. Okay, and it's obviously, as you can see, it's the shadow areas where you're typically getting this noise. Okay, okay, great. Another area that we can get noise from is from our rays. So what you need to keep in mind is that Arnold is actually kind of rendering out 5 kind of images, okay, or is actually kind of looking at, basically imagine what Arnold is doing is throwing light into our scene and then basically seeing what light comes back. Okay, and in doing that, it actually emits 5 different types of light that interact with surfaces in 5 different types of ways. So we've got our kind of diffuse light, okay, which is our kind of scattered light that kind of bounces randomly. We've got our specular light that bounces kind of directly at the angle of incidence, so it doesn't just bounce randomly everywhere. It bounces in specific directions. We've got our transmission, that's light that goes through transparent objects and refracts. We've got our subsurface scattering, so that's light that's coming into an object and scattering inside the object and then leaving the object in our subsurface scattered surfaces. And then we've got our volume indirect, and that's light that's interacting with any kind of volumetric elements that we've got in our scene. In this case, we haven't got any volumetric elements. Okay, so important thing to realize is that this camera AA is basically kind of a multiplier or a scaler that scales all of these attributes. So if I increase this, I'm effectively increasing all of these rays. Okay, and so what we're doing is we're and so to understand the total number of rays that we're putting into a scene, what we want to do is take the square of this camera AA and multiply that by the square of this diffuse. So the best way to imagine it is imagine this camera AA is kind of for each pixel, our camera AA is subdividing that pixel into a 3x3 grid, and then within each cell inside that 3x3 grid, this diffuse is actually dividing that up into a 2x2. It's dividing that cell up into a 2x2 grid, hence the multiplication. So if I just get my calculator out, just here, just to kind of show you this. So 3 times 3 is 9, 2x2, 2 times 2 is 4, so 9 times 4, sorry, 4 equals 36. So you can see that we've got 36 rays here, and you can see it tells you the number of rays you've got here. It's telling you those rays here. Okay, and what you'll see is these are all the different rays that you've got, and it's telling you how many of these rays, and then it's giving you a total for those rays here. Okay, and obviously the more, and that obviously is the total number of rays per pixel that are being put into your scene. Okay, so a good way of inspecting your scene is to use something called AOVs. And what AOVs allow you to do is actually isolate these different types of rays so that you can kind of see where the noise is coming from. So let me give you an example of that. I'm just going to come back into here. So if I go into my render settings, what you'll see is I've already set up the AOVs. So the way you set up an AOV is you just select the output, the type of output value you want to, the type of output value you want, and then, so for example, if I click Z here and click this arrow, it's then going to give me these Z values here inside of my AOVs. Okay, I don't want that, so I'm going to click back. But basically, I've selected all of these from here and put them into there. Okay, what that does for us then is when I'm rendering, so I'm just going to trigger a render again. So when I'm rendering, what that does then is, rather than just having a beauty pass, which has all of these light elements composited together, I can actually look at these individual light elements and see what noise is inside of each of those light elements. There we go. So as an example, if I take subsurface scattering, what I can do is I can go in here and I can I can see there's a fair bit of noise in there, and I can go in here and up the number of rays for my subsurface scattering. So if I put that up to say 4, what you should see is that you can see that there's much less noise here, and if I go into my beauty pass, you can see that my subsurface scattering has less noise in it, and I've still got noise in other channels, but you can see that my subsurface scattering has significantly less noise in it now. Okay, so that's how we can kind of, and you can obviously just tune each of these inside independently. Okay, I'm just going to come back to kind of how you might do this a bit more methodically than we've done here in a moment. But what I want to do right now is just continue on to the next slide. So yeah, we can remove noise from each of these areas, obviously by upping the number of samples for each of these ray counts. Great. Okay. What we can also do is we can, if you've got a camera with motion blur or depth of field applied to it, what you'll find is, in order to see that, you want to have a look at the alpha channel. Okay, and in order to get rid of that, you can't really just up a particular ray. You need to up the camera AA, which obviously multiplies all the rays. Okay, that's a key point with this. Okay, so for example, I'm just going to go back to my render now. Okay, inside this image, I actually have a depth of field, and so this kind of helps you understand maybe the implications of rendering out depth of field and motion blur within Arnold, because what that means is you're typically going to have to up your camera AA samples quite significantly, which will obviously then multiply all your other rays quite significantly. So we can see here, I've got depth of field applied. I've actually applied to this, and what that's doing is it's generating a lot of noise. You can see on the edges here. If I click on this, just going to go into my alpha. Here we go. So with my alpha channel and my sort of isolate selected geometry selected here, you can see I can see all the noise that's been created by this depth of field. I've got no motion. There's no motion in this, so there'll be no motion blur in there, and I haven't got motion blur being rendered in my camera settings, but I have got depth of field. So in order to get rid of this, I'm going to have to up my rays. So what I might as well do is just drop down these rays, the SS back down to 2, and really kind of in this case my best starting point is upping the camera AA in order to get rid of this, and I've got to put it up fairly high, so I'm going to put it up to say 5. Now what we can do is in order to kind of focus on where we're looking at our noise, what I can do is I can just go and press shift, so I could just hold down shift and select an area, and it will just render this one area. So we can kind of see, yeah, we've still got a bit of noise there. I could push that up even more. Let's have a look what that looks like. Okay, there we go. So you can see I've had to push this up quite high, which will already push up these other rays. So let's have a look what this looks like. So I'm going to turn this off. Now we're happy with the motion blur that we're getting. Sorry, I'm going to turn off isolated, and just go back to our RGB, and then remove that. Let's have a look what our noise looks like on our other surfaces. So I can just go, I can use Shift Select to kind of select different surfaces that I've got. So I can kind of go into here, and I can just look at my transmission. So this will be my transmission surface rays for my. This will give me an idea of my transmission rays here. Again, I could just isolate the AOV. Yeah, and I can still see I've got a bit of transmission noise in there, so I could up these rays a little bit. Let's have a look. And you can see this is impacting the render time now. And I can go through my scene, looking at all the rays sort of independently in this sort of manner, okay? But typically what you would do is look at anything that's completely dependent on your camera AA. So I was thinking of like the depth of field and motion blur if you've got that applied. And then really beyond that, you can kind of go through them in this kind of order, looking at the different parts of your scene and upping the rays. So coming back to the presentation then, the final slide that I wanted to have a look at really was this sort of table here. And this is really just kind of a cleanup, a sleuthing table. This is directly off the Solid Angle website. And this just kind of says, where are you seeing your noise and where to get rid of that noise. Okay, so for example, with our depth of field, we've got noise in our alpha channel, and the way to get rid of that is to multiply it by our camera AA samples. And you can see you can use this table accordingly to kind of figure out where to up your samples in order to get rid of noise. And the key thing is when you've got noise in your diffuse specular, okay, in your direct specular and your direct diffuse, that tends to indicate light noise in your light samples. Okay, yeah, it's so when you've got it in your indirect here, then that's going to be your diffuse and specular samples that you want to have a look at. Okay, so yeah, I'm going to leave you with that, and hopefully that's giving you some ideas of how to efficiently remove noise from your scene in Arnold. Obviously, we can just up the camera AA to ridiculous levels, but that's not the most efficient way of doing it. What we want to try and do is target where we need those samples increased so that we're getting the render we want, but in a sort of the most efficient manner possible. Okay, thank you for listening.